So this is what we were doing in the other class. Can you solve for x if the fractions are equivalent? And we looked at these two methods. The algebraic method, where you have to do the same operation on both sides. And usually we had x over a number, like we had x over 20 or x over 4, and we were dividing by 20, or we were dividing by 4. Like in this first example, we were dividing by 20. Then the opposite of dividing by 20 was multiplying by 20. So when we multiplied both sides by 20, these 20s on the left-hand side canceled out, and then we just had x, and the rest we could put into our calculator. 2 divided by 5 times 20, and then we would have gotten 8. So that was the algebraic method, where what you do to one side of the equation, in that last example we multiplied by 20, you do to the other side of the equation. Now in the pattern method, when we're looking at equivalent fractions, you might see that you get an equivalent fraction by multiplying the top and the bottom by the same number, or dividing the top and the bottom of the fraction by the same number. So in this first example, on the right side with the patterns, we notice that to go from 5 to 20 in a fraction, I multiplied by 4. If I did that same thing on the top of my fraction, then that pattern would hold, and those fractions would be equivalent. So that was the pattern method, where we look for the same thing. And something in the pattern method, because when we did this first one, I drew the arrow this way and we multiplied, and then in the second example in the pattern method, where we had 15 over 20 and x over 4, some people were asking, well, last time you multiplied, why did you divide this time? So something to notice in both of these ones with the pattern method, when I was working on the pattern method, I always drew an arrow to the x that I was solving for. So I wanted to find this x, so I drew my arrow this way to the x. And then I did the same direction here. In this way, I noticed to go from 5 to 20, then I would have to multiply by 4. Well, in this second example, when I was looking at it, okay, I want to go to this x this way, so I have to go the same direction in the pattern here. Well, now I'm going from 20 to 4, so that's why I divided. It's not wrong if you always want to multiply. Like someone said, I did it this way. I noticed from 4 to 20 was times by 5, so I had to do the same thing from x times by 5 to get 15, and then they figured out that it would have to be 3, because 3 times 5 is 15. So let's do one more example here, both the algebra method and the pattern method. And again, I'll give you a head start to see if you can do it on your own. And then we'll put up the answers to see how you did. So for the algebra method, right now we have x divided by 18 equals 1 over 6. And the opposite of dividing by 18 would be to multiply by 18. So if I multiply one side of the equation by 18, I have to multiply the other side of the equation by 18. Here, multiplying and dividing by 18 at the same time is equal to 1, so it doesn't do any difference. So we end up just getting that x is equal to, and when we type this into our calculator, do the math, we'll get 3. On the pattern side, we want to find out what x is. So if I want to go from 1 to x, and looking at going from 6 to 18, here I have to times by 3 if I'm going from 6 to 18. So up here, I'd have to times by 3, and 1 times by 3 tells me that x has to be equal to 3. Now, if you did the algebra method and the pattern method and got a different number with the two methods, then you know one of them something went wrong in one of them, because it should be the same answer either way. It could be that something went wrong in both of them. I guess that's a possibility too.